Okay, here we are. We're kind of coming to the home stretch. Now we're going to talk about adding and subtracting rational expressions and functions, all right? So let's say hypothetically we have, now let's just look at some basic things like 4 divided by 2 plus 6 divided by 2 equals, okay? Now, when we're adding rational expressions, like you saw in the other videos, when it was multiplication, right? So when we were multiplying, let's say 4 divided by 2 times 6 divided by 2, okay? We multiplied across. 4 times 6 is 24. 2 times 2 is 4. And we got 6, right? And this is when we're multiplying. So now if we look at an example where we're adding, your first inclination might be to add across, right? And that's actually not the case. And the reason why that's not the case, well, we're actually going to go over that, at least in the basic level, is let's actually solve this out, right? What's 4 divided by 2? Well, that's 2 plus what's 6 divided by 2, which is 3, which is equal to 5. Okay, so if we wanted to try to find a way to get this entire expression to equal 5, well, the only logical thing we can do is just add the numerator. So we're going to get 4 plus 6 all divided by 2. Now, because the numerator is the same, it has to stay the same, okay? We don't add the numerators, we don't multiply it, it's the same. We just combine it into a single fraction. 4 plus 6, well, that's just going to be 10 divided by 2, which is equal to 5. And that makes sense. So you could see another scenario. We have 3 divided by 2 plus 5 divided by 2. Well, that's going to be 3 plus 5, all divided by 2. 5, 6, 7, 8 divided by 2, which is equal to 4. Perfect, okay? And it applies when you're subtracting. So we have 4 divided by 2 minus 6 divided by 2. Well, that's just going to be 4 minus 6 all divided by 2, which is negative 2 divided by 2, which is negative 1. Okay, so that's kind of how the properties work. So when we have like terms, we just either add the numerator or just subtract the numerator. So now let's go to an example problem that's going to involve rational functions. So let's look at something like this right here, which is going to be let's say we're going to have 4 over x plus 3, okay, plus x minus 2 all divided by x plus 3. Okay, well, we first ask ourselves, are the numerators the same? Yeah, the numerators are the same. And so all we do then is just combine the top, right? 4 plus x minus 2 all divided by, well, x plus 3. Okay. Now if it's helpful, we'll just rearrange the top since we're just adding, subtracting. This is 4 minus 2 plus x all divided by x plus 3. So last but not least, we're going to get 2, right? 4 minus 2 is 2. 2 plus x all divided by x plus 3. And we can finally write it as just x plus 2 divided by x plus 3. And that's my final expression, okay? Now, if you wanted to, right away from this step, we could have gone, well, 4 minus 2 is 2. So we're just going to get x plus 2, all divided by x plus 3. So you could see that we don't even need to do a lot of this work, but we can if we want to. I just want to show you how to organize it. Now you can see, well, x plus 2 and x plus 3 are two completely different factors, so there is nothing that we could do, and so we're literally done, and so we just go ahead and move on. So, well, we're good. Let's maybe look at another example problem. I think that is a little bit more fruitful. Let's look at x squared. Let's look at x squared plus 3x minus 2 all divided by x plus 5, x minus 5, okay, plus, let's say, 4x plus 12, all divided by x plus 5 and x minus 5, okay? So let's look at this right here. Now, again, you'll have to first ask yourself, do we have like denominators? And we sure in fact do, right? We have x plus 5, x minus 5 here, and x plus 5, x minus 5. So we can combine it into a single, fraction. The denominator, again, stays the same. Okay, it stays the same. We don't change it. Now let's go ahead and focus on the top, right? We have x squared plus 3x minus 2 plus 4x plus 12. Okay, so therefore we're going to get, well, there's only an x squared. Again, I'm going to write this as x plus 5, x minus 5. We have 3x plus 4x, which is plus 7x. And then we have negative 2 plus 12, which is plus 10. Okay, and now you could see we basically just added the numerator, simplified, and now that it's simplified, we can definitely we can ask ourselves, right, well, maybe is the numerator factorable? Maybe we can turn this into factored form. All right, first thing you might want to do is write all the factors of 10, 1, 10, 2, and 5. Well, 2 plus 5 is what's going to give me the 7 there. So I'll go ahead and write this as, well, x plus 2, x plus 5. And you can see that now this is going to be very nice because these are going to cancel out, and all we're going to be left with is x plus 2 all divided by x minus 5. Okay, and we're good, we're solid. So you could see this is just a scenario where we're just adding. All right, so hopefully that's helpful for you, just seeing example problems that are strictly just adding, and then we'll go over some more in-depth problems with